So 7.1.4, stating hypotheses. So identify the hypotheses necessary to test the following statements, and then classify the hypotheses as a left-tailed, right-tailed, or two-tailed test. In each case, you first need to define in context the random variable and the parameter. So part A says the average salary of a teacher is more than $30,000. So in here we're looking at money, which is quantitative, and it's, we're talking about averages or means. So that means our random variable is going to be x bar, and our parameter will be mu. Okay, so mu is going to be the mean salary of all teachers. So again, remember mu stands for the population mean, so we need the word mean in there, and population all. And so the random variable x bar stands for sample mean, so we need mean in there and the sample size, so the mean salary, and they didn't tell us how many, so we'll just say of a random sample of teachers. Alright, so now in setting up the hypotheses, they are trying to show that the mean is greater than 30,000, so that's going to be all our alternative hypothesis. And again, the null hypothesis is always the hypothesis of no change, so it always has an equal sign. So in here for the null hypothesis, we're going to have the null hypothesis going to be that the mean equals $30,000. And again, if we believe that, there would be no further testing. But if we think we have evidence to the contrary, and in this case they feel that that average salary now is more than $30,000. So since the alternative hypothesis states that the parameter is greater than claimed, okay, this will be a right-tailed test, which means if we actually had some data and performed the hypothesis test, okay, the p-value would be that area in the shaded right tail of the distribution. All right, so for part B, the proportion of students who like math is less than 10%. That is super sad. Okay, so in this case, we would be asking students if they like math, and so that would be yes or no. So we would be dealing with qualitative data. So let's go back up here. We talked about it, but didn't really write it off here, so we had quantitative data. So for qualitative data in this particular entry-level course, we're going to be focusing on proportions or percentages. So in this case, our parameter P is going to be the proportion or percentage of all students who like math. And then the random variable p hat from the sample. Okay, this is going to be, and they didn't give us a sample size yet, so we would just say the proportion of a random sample of students. Well, we've been using that for randomly selected, so maybe we should fill in that word, random sample. The proportion of a random sample of students who like math. And again, we would take some value of p hat to try to get some information about the true value of p. So in the statement up here, somebody is making the claim that that is less than 10%. So that becomes our alternative hypothesis. The null hypothesis is a statement of no change, so it would say that p equals 10%. So since the alternative hypothesis states that the parameter is smaller than claimed, this would be a left-tailed test. And so again, if we were to actually perform the hypothesis test, we would find that, again, we're trying to find if we have an unusually low value, so we would have a shading in that low or left tail. Okay, and the last one here, we've got the average age of student in this class differs from 21. So now we're looking at age. So again, another quantitative variable, which means in this course we're going to be focusing on means. So in this case, the population mean would be the mean age of all students in this class, which means our random variable x bar, sample mean here, would be the mean age. And again, we don't have a sample size, so we would just say of a random sample of students in this class. All right, so in this case, they're making the guess that that average age differs from 21. So that means our alternative would say that mu is not equal to, so differs from is a not equal to sign, differs from 21. And again, the null hypothesis is always a statement about no change, so mu equals 21. In this case, since the alternative hypothesis states that the parameter is different from claimed, this would be what we call a two-tailed test. Okay, because in here the p-value would actually be a shaded region a little bit in the left and a little bit in the right together, so two tails.